Uh, so you guys are able to see the screen?
Yep.
Yep.
Hmm, cool. So first of all, I skipped the most of the obvious stuff. We won't be probably we won't be going into the coding part or writing commands or etc. anything like that. I have skipped all of it. Tried to take a different perspective. Went into some history and like there are some things I think I mean some of you might already know, but there are some things like I did not know for a very long time, and that always like pricked my brain. So I thought maybe I'll deep dive into them, and I read a lot of the articles and the history, and then kind of accumulated everything into this talk. This is going to be a very short. The idea is that going forward, each one of us shares their ideas, and yeah, including whatever if there is some new project. That you did or anything related to capital or outside capital or outside JCP, like a platform to just share ideas. So this I'll try to make it as fun as possible. Please feel free to pull my leg, and here it goes. Capital Talks 1. So although it's called shell Koans, I think it's more about terminal and shell. We'll see going forward. So the agenda for today is we are starting with something called teletype devices. I'll go in a little bit of detail what it is, then a little bit about terminals, emulators, and then the shell stuff and some of the special characters in the ASCII, how the colors work, what is a Posix shell, and everyday usage is just a bunch of shortcuts in one page. I've seen while screen sharing a couple of the folks struggling, so I thought maybe I could share some shortcuts that I use. So let's begin. You can, by the way, stop me anytime if you have any question. Um, so let's dive deep. So this is a Bodo device. I don't exactly know. It is also known as piano, I guess. These were like early devices which were used for telegraphy, as in sending messages. They had these 5 keys. Uh, by the way, I'm audible, right? If there is a network issue, please let me know. I mean, if someone can give me a constant feedback that yeah, I'm available or like I'm audible.
Audible.
Cool,
Yeah,
cool,
you're
thanks.
audible.
Cool. So this device was used for sending messages. So these had like this 5 keys, and they were used like different combinations would send a different character, and that's how the entire English was encoded, and they were the messages were sent, and the encoding was happening using Bodo encoding, and that was long before ASCII came into existence. Uh, I mean, ASCII came near about like 80 years after this of such, and this was the primary communication back then. So the idea was that whatever the key presses you do, they will be encoded, transmitted, and then sent. At the other end, someone can receive it, decode it, and they can print it out. So moving forward, eventually, the five keys were replaced with keyboards, where a lot of like that came to know known as teletype writers instead of teletype devices. I mean, both are synonymous. Don't really make any difference these days or before. So the TT wise, if you're getting an idea where I'm getting, you would have seen TT wise written on the black screens if you have used a Linux terminal. Uh, we'll go in detail of that in that direction. So teletype devices used to look like this. They had this paper roll which you could type in, and whatever input output you wanted to give, like output would be printed on top of these papers. These were electromechanical devices, and the messages were sent over telex. Telex was a network that was predominant before fax, and yeah, these were the devices just simply for communication, no computing, nothing. These were like nothing. These devices have nothing to do with computers at all, but just communication. So when these came in, so they started like some kind of encoding. I guess these devices started. Uh, no, Bodo encoding was like there prominent for a while, and then I guess they switched back to ASCII. I'm not sure about the exact time when they started. Uh, so also like there were different companies making these, and everyone had like a different standard, etc. So that was it. Then, like how did computers and teletypewriters, like relate to each other? Why am I talking about this? So let's come to computers. So what had happened with computers were like the computers were like huge machines. They were like situated in the basement, occupying the entire room, and they were evolving with time. They were becoming more time sharing, as in multi-user, tasking support, and this the punch cards, like they were going extinct. To interact with computer using a punch card did not make any sense because they were not efficient. So that's where the teletypewriters came in. So people thought, like, why can't we use this, the teletypewriter, for communicating with the computer? And okay, then if we allow the teletypewriter to, just make sure that the encoding is understood on the both sides, then we can use this device to communicate with the computers. And that's how the teletypewriters came in combination with the computers. And these, when combined, they were called as terminals. So that was the first time when, like, that's how terminals started. So if you're wondering, like, how exactly were the computers back then, I mean, the block diagram of it would look something like, sorry, like this. So the idea was that these were like large organizations like schools and companies like Bell Labs. They were able to afford these huge computers. So they had these kind of computers in their basements, and wires coming out. And let's say multiple users wanted to use the computer, so each of them were given a terminal. So again, remember the terminal was like this, and uh, very quickly that changed, and those paper rolls and everything were replaced, and that became hardware consoles. Before coming there, like uh, the setup, I'll talk a little bit about the setup. So these were the days where, like, there was one computer and multiple people wanted to use it, and they had to take a permission and reserve a slot to actually use the computer. And for huge computations, they had to leave it overnight. And these terminals were like out there, either in the offices or out there available for people outside the computer room, for people to interact with the computers. So when these were replaced, these are more compact and much more modern systems, where the paper rolls were replaced with the CRT tubes, with some basic functionality, like moving the cursor around, clearing the screen, bolding the text, etc. So these were electromechanical, and these became electronic. And these were also known as like video display terminals. Uh, so this is again one type of terminal which was connected to some mainframe in some basement, and you could send instructions through this to the computer, and the computer would do the some magic, and it would respond back with the output, and that's how you would be able to see the uh, whatever the output is returned from the operating system. So far good. Any questions? Am I audible? Still audible?
Still
Yeah.
audible.
Cool. Uh, Moving forward, back to present. So what happened now is Okay, let me connect this with the current present. So how many of you guys have like faced, seen this screen, some random button presses and you landed on this screen while using a Linux system? Anyone?
Yeah.
Right. So this, for a very long time, I did not know how exactly these things internally mapped. So these are actually the terminals which you saw here, the hardware consoles. These directly map to this. What's interesting is that these TTYs, these are again teletype, pseudo teletype devices. Sorry, teletype devices where direct this pseudo is one second. So these teletype devices, they are directly mapped to the hardware drivers. So they have a device file in the Linux system to which they are mapped. So these are as good as hardware connected devices, except that that hardware was emulated. We'll come back to it. I mean, go in more detail about it. But then, yeah, these are these TTY screens. Let's say if you do not really have a graphical environment, and if you boot into a Ubuntu system without GNOME or Unity, what would happen is that you would land up on such a screen, and you will have to run the graphical interface using StarText or something, and that happens on this console. So you can what you can do is, like, if you have a Linux system with you, you can maybe try Control Alt F1, F2, F3, or any key press, and the F1 or F2 would be either one of it would be already used by the graphical interface that you logged in. But if you want to access others, you can go up till F7 or F6, depending on the distro again. So going forward, these once you log in and start the graphical interface, right? So these programs, a bunch of programs are started, and what happens is that, let's say you open up a terminal. What happens when you open up a terminal? So the terminal, as in the kind of item to kind of a terminal. So the idea there is that so these are the virtual terminals, the terminals which are mapped directly to this kind of thing. So these can be multiplexed. These are multiplexed at at the software level, and they are multiplexed to something called pseudo teletype devices. So these are TTYs. Sorry, these are TTYs, the virtual terminals, and the multiplexed ones are pseudo teletypes, teletype devices, which are PTS. So if you open some terminal and type TTY in that, and you would see dev/PTS and some number, depending on number of terminals you have opened and the ID the terminal has. So what exactly is happening there is that these pseudo TTYs are, you can create multiple pseudo TTYs, and that is handled by a program called terminal emulator. And what is a terminal emulator? Your item 2 is a terminal emulator, and there are a bunch of more external console, and there are a lot more terminal emulators available. And these programs take care of talking, talking to establishing a connection between your PTS, pseudo teletype devices, to your TTYs. This the main one which runs in the background. So this don't get confused with the tmux. Tmux is a different program altogether that has nothing to do with this terminal multiplexing. There is this file in Linux systems. It's dev ptmx. This is like used to communicate with the kernel. So in Unix and Linux systems, in Unix like systems, mostly everything is a file. So every device you want to communicate with is a file, and every device file has some drivers associated with them. So so that they know that when we write into that file, how they are going to be modified, or the sequence of data is put in a format that the device can actually understand. That's the point of device drivers. So similarly, like this file is what. So what would usually happen is that you would take a lock, kind of a lock on this file, and then establish a connection with it with your PTS, your sudo TTY, and when you run a command, that's what happens. You establish a connection with this file, and then the data is transferred serially from your PTS to here, and it comes back. So with that, I want to like clear out some stuff. This is a hardware emulated terminal, and this is a software emulated terminal. That's the primary difference is that this terminal, the TTY, this is connected to hardware, and this is connected to a software. How is that? So one end here is connected to a device driver, so device file, and another end is hello. Yeah.
Audible.
Sorry, my connection was unstable.
Okay. Okay. Yeah. So this TTY is actually a terminal that one side it is connected to the device file, the hardware. You can think it's not the real hardware. It's again emulated hardware. Like I said, the serial back in those days, the VGA kind of ports, serial ports were used, and these are emulated ports. Hardware is emulated in the software itself, and they are connected to those device files. But here, one side is connected to a TTY, this TTY, and other side is connected. So not this exactly. Terminal emulators use that behind the scenes. So one side is connected to the terminal emulator, and another side is to shell program or a login program. So so far clear. I mean, did you guys understand what I'm trying to share here?
Yeah.
Any questions? Okay. So coming back to the terminal multiplexer. So these multiplexers are the mechanism to share the main TTY and split them into multiple PTS, which is a pseudo teletype writer, and share, split it, and you make it available for multi-user and multiprocessor. So if you log into your Linux, and if you do a WHO, you will see that you have logged into a TTY. This is the virtual terminal, not the sudo, and this is the sudo terminal. This, when you do a TTY on a terminal emulator, this is what you will see. Things are slightly different on the Mac side. They pretty much, I think, emulate pretty much everything. They do not expose out the TTY, the main, the virtual TTY. So I'm going to refer to virtual terminals as TTY, and these ones as the pseudo terminal teletypes as PTS, just for the ease. Right. So coming to shell, now that you know what is a terminal is just a communication mode with the computer. It's way different from shell, which is commonly misunderstood. So shell is a command line interpreter. It just starts some programs, and it's between the user and the software. So if you want to run a command, it takes that command and runs it. So how, if you see now that I've established that both are different, like what responsibilities are of terminal and what are of shell. So for example, line editing, input history, the scrolling that you do, and the auto completion, etc. They are provided by the shell program. Sorry, the line editing. Yeah, right. So the output history is like whenever you type a command, run a command, and the output of the command that is printed onto the screen. When you also the copy paste of it, etc. That is a terminal concept given by your terminal emulator. So knowing these differences, you'll be able to decide like if you face a particular kind of an issue, you will know whether it's a shell issue or you need another try out another terminal emulator or fix the bug or something, raise the bug. So what happens when you do something like Control C and Control Z? So I've written something here, right? Control C end of text, and which is usually used to kill the job. And Control Z is I've written substitute, which suspends the job. So terminal handles these kind of special characters. So we'll talk about it. We'll just look in detail. So what happens is terminal converts these key presses into control sequences. We'll again look at control sequences in the next slide. And the shell converts these control sequences into commands. So what is a control sequence here? Whatever I've written in the bracket, these are the control sequences. So let's take a closer look at the control sequences. So these are the control sequences or control characters from the ASCII. In ASCII, there are like a few characters that are not meant to be shared. They're not meant to be seen as text. So the characters have like some special meaning, and they are not intended for the display. So for them, I'm just sharing some of them. There are a lot more, around 31 of them, 0 to 31 and 127. You can see for each of the control character, there is a caret notation. Caret notation is often used in terminals to display the control characters. These are control characters. Caret notation is used to display in terminals. And escape, this is also a kind of a notation that is used in programming languages and some other functions. The interesting part is that there are certain certain things that you can do without using the specified key. For example, backspace. So there are a lot more. We'll have a look at them quickly. Any questions here, by the way? Okay. Am I still audible?
Yeah, Vijay, you're audible. Able to you.
Okay. Let's do a quick hands-on. Can you guys, open up your terminal and try and type this? Type GIT without any spaces and do a Control H. The meeting ends in 10 minutes. What happens? Control H. It's a backspace, right? So why is that happening? That's because Control H is actually the triggering the control character backspace, and that's how the shell is the terminal is interpreting it as a backspace. Similarly, if you do a Control I here, this is actually equivalent of doing a tab, right? So it gives me this set of if you are able to see my screen, it gives a set of auto completion. Did you try running echo \A? That should give a beep. So that's because \A is mapped to bell sequence, control sequence. So these are some fun stuff you can try. So now that we know, like, there's like the difference and the responsibilities between the shell and the terminal, like how does they communicate? How does like I said, like terminal converts these and sends these control sequences to shell, and then shell gives out output. But then these things are happening, and then what exactly is the way of communication? It's actually a in-band kind of a communication where, let's say, in a sequence of zeros and ones, if there is a special sequence inside that, it is taken considered as a command instead of simply trying to display it. The terminal will take it as a command and it will interpret it as something else. Like for example, colors. So for colors, just like very small thing that you can do a lot more. Just a very minor thing. So this is how a shell emits instructions. It says like print ABC, then switch the foreground color to green, and then print XYZ. Now the XYZ will be printed in green color. So the terminal simply acts on these instructions. If you just echo this kind of this works on Zeesh, by the way. If you're trying bash, then use printf. So if you echo this, so let's try this. So let's say I try x 0b1 or x1b. Okay, x1b is nothing but escape. Again, if I go back here, somewhere it should be. Okay, I'm not included here, but it's escape. And then you can start the control, and whatever you give here is a command, and then you close it. It's like HTML open brackets and closing brackets, and whatever here is the command. So this one is actually used for bold. So I can do this, and whatever I type after this is going to be in bold. Are you able to see my screen, by the way?
Yeah, Vijay, we are able to see you.
The terminal that I'm sharing right now. Okay. So in Bash, things are slightly different. Once you turn on a bit, let's say the bold bit, you have to explicitly turn it off, call it 0, and only then it will shut down. So you can try out these things like you can start with the escape character and then open control start, and you can separate these commands with semicolons. One is italic, one is bold, 3 is italic, I think 4 is underlined, and 31 is red color. So that's how the communication between shell and terminal happens. You can give it a try in your free time. So check out this library called ncurses. That's how most of the terminal-based UIs are built. So they give out some APIs which you can use and use to do some interesting stuff. The programs like HTOP, they use this library. Okay. So just wanted to I think 2 more slides. So just wanted to talk about Posix Shell. So Posix is a standard, while all the others, the Bash, Zeesh, and Fish, are implementations. So all the Unix-like operating systems, they have a file called bin.sh, so which is actually expected to point to a shell implementation. So by default, sh is so the shell sh is actually a simple standard, but not a implementation. It becomes once you implement a shell, then you can point this to that particular implementation. And if you in Linux systems, at least if you do LSL and bin bash, you'll see that it is pointing to bash. So if this can be anything based on your preference. So Posix, again, the syntax is different for some syntax is different for Bash, Zeesh, but both Bash and Zeesh, they can run in Posix mode. By default, they do not run in Posix mode. There is a program although called check shell, which will make sure that if you have written a Bash or a Zeesh script, it will check if it is Posix compatible. Maybe you can check it out. Last slide, some of the navigation shortcuts. So one thing, if you want to, most of you might know this, if you want to go back and search your history for a command, you can do a Control R, and that will give the, and you can, yeah, it'll autofill the command, and you can keep pressing Control R, and if there is anything other than this, it'll start looping, and then yeah, repeatedly cycle through matches. Control A is for beginning. So control, if I'm my cursor is at the end of the line and you want to change something at the beginning of the line at the terminal, you can use Control A to come to the first. Similarly, Control E back to the end of the line, and like, yeah, there is a alternative to, so yeah, also most of you, I don't know how you clear your screen. If you type in clear and clear your screen, you can also do Control L, which simply clears the screen. That's for navigation. There are some also, if you want to simply delete everything on the terminal prompt, you can use Control U. That will clear everything before the cursor. Control K is after the cursor. Some more helpful shortcuts. Let's say you have a very big command, a very long command. If you do a Control XE, that command will open up inside your editor, whatever you have put in your editor variable, environment variable, and you can make the necessary changes. And you close it, it comes back here, and you can run it. Were you able to see my screen where I shared the terminal?
Yes.
Yeah.
Cool. Yeah, one more interesting thing is usage of double exclamations. Let's say you ran a command, and let's say it gives an error saying that permission denied, and you want to run the same thing with the sudo. You can try this. So that will just copy whatever was there, whatever was run previously. So these double exclamations are replaced by the previous command. Yeah, one last interesting thing is, let's say a lot of the times when you're debugging some logs, and you're doing some writing lengthy commands, and let's say, for example, you'll do git pull origin master or something, and then you want to do the same thing. Just an example. Now I want to git push origin, and just you want the last argument back here, then you can simply say escape dot, and that will bring the last argument here. Alternatively, you can also try this. This will also replace it.